What's up guys, and welcome back to the channel. Today we're faced with another problem from the May-June 2022 paper 32 paper for CIE. This time it's a vector line problem. Similar to the other question in this paper, over here we have the issue where, according to the examiner, this was a challenge because it was different to anything the students may have seen before. In addition, for this particular question, several candidates made multiple attempts to obtain the answer, which shows you that it's not as simple as it may seem. Making things worse is that this question as a whole represents about 13% of the overall paper. So similar to the other question, it's a double whammy. It's difficult, but yet worth so much from a marking perspective. To start off here, the key word to focus on is intersect, because that provides a hint as to what we should do mathematically. That means that step one would be that we have to create a system of simultaneous equations. And when we do that, we get the following. Now, notice something else. The equation they want us to prove is in terms of B and A. This is important because it highlights the need to eliminate other variables, specifically lambda and mu. This means that step 2 would entail rearranging each equation like so. I picked mu to be the subject, but you could have easily have done lambda. But wait, there's a problem in both 1 and 2. The problem here is that we have 3 variables, which means we can't generate an equation in terms of A and B. We need to plug in equation 3 in order to give us an equation only in terms of A firstly and then B after. Therefore, we get lambda equaling A plus 6 over A plus 2, and lambda equaling B plus 1 over B minus 1. Now, once we equate these, we get 2B minus 4, and then finally 2B minus A equals 4 after rearranging the equation, and then dividing by 2. Right guys, now for number B it says, given that L and M are perpendicular, find the values of A and B. So, how do we go about doing this? Well, what you need to recognize is that, okay, if L and M are perpendicular, that means the direction vectors, when you apply the dot product, must equal 0. Okay? So if we look at that, the direction vector here is 2, negative 1, negative 1. Okay. If we apply the dot product there with the other direction vector, that's AB1. Okay. Okay, so what does that equal? That's going to equal 0. That's the basis and foundation for this question. So using that, we can say 2a minus b minus 1 is equal to 0. Okay, so that's our first equation here. And what else do we know? Well, we know that 2b minus a equals 4 from the previous equation. Okay, 2b minus a equals 4, which implies that a is equal to 2b minus 4. So we've got this, and we can plug this now into this. So if we do that, we get 2b minus 4 minus b minus 1 is equal to 0. Okay? Which means then that 4b minus 8 minus b minus 1 is equal to 0. 3b minus 9 is equal to 0 then, which means B is equal to 3. Meanwhile, A is equal to 2, 3 minus 4, which means that A is going to equal 2. Okay? And that's going to be our final answer there. Alright guys, so now it says when A and B have these values, find the position vector of the point of intersection of L and M. So to break this down, position vector, keyword, point of intersection, keyword, L and M, keyword. Okay, with 3 keywords there. So position vector, okay, L and M intersection. All that means is we need to find lambda or mu, okay, and plug it into any of these equations. I'm going to choose lambda because it's easier. But in essence, this is what this represents, because this is the point of intersection. So if we find lambda, okay, lambda is equal to a plus 6 over a plus 2, which equals 8 over 4, which equals 2. Okay. Therefore, applying this to a point of intersection, minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. Okay. We got minus 1 plus 2, times 2, 3 minus 2, 4 minus 2. And that's going to equal 3, 1, 2. Okay. Very simple. All we have to do is plug in our value for lambda, and this is going to be the position vector here.